Welcome everyone to week 1 of February Flare Up Health Edition. You can join us every Friday in February to learn about health and wildfires. Canada Wildfire's head office, where I am located, is on Treaty 6 territory, a territory rich with many histories, languages, and cultures of First Nations, Métis, Inuit, and many First Peoples of Canada. Today, we're going to be learning about the knowns and unknowns of wildfire smoke. I'm very excited to introduce to you two great speakers. First off today, we're going to have Dr. Sarah Henderson, and once she's done talking to us, we're going to have Brian Wiens talking to us about smoke models. First off, we're going to have Dr. Henderson. She is the Scientific Director of Environmental Health Services at the British Columbia Centre for Disease Control, and also of the National Collaborating Centre for Environmental Health. She's also an Associate Professor at the University of British Columbia School of Population and Public Health. Today, Dr. Henderson is going to be talking to us about the knowns and unknowns of wildfire smoke. So with that, I'm going to hand it over to Dr. Henderson. Thank you so much for joining us today.
Good morning, everybody. Nice to see some familiar faces and many not familiar faces in the crowd here. Can I just confirm that you are able to share my screen, see my screen okay?
Yes, it looks great.
Perfect. Okay, well, thank you for the nice introduction, and thanks for coming out to the first week of the February flare-up. As noted, I'm the Scientific Director of Environmental Health Services at BC Centre for Disease Control, and that is a public health agency in British Columbia. So I take a very public health perspective on wildfire smoke. I've been studying this exposure for more than 20 years now, and I'm just hoping to give you an overview of what we know, what we don't know, and some context for what that means in the world of wildland fire fighters. There we go. I want to begin by acknowledging that I am currently on the traditional and unceded territory of the Musqueam people. I'm on the Point Grey campus of the University of British Columbia right now, and let's take a moment to consider how colonial that name is, the University of British Columbia. And take a moment to consider that whenever we're talking about the impacts of wildland fire and wildland fire smoke, we really do have to remember that these events have a disproportionate effect on Indigenous people in Canada, both in terms of the physical environment and mental and emotional well-being. So I like to remind everyone to try to keep that at the forefront of their thinking when they're talking about wildfires and smoke. Now, this is going to be a pretty interactive presentation today. I am assuming that everybody's got a cell phone or a second monitor that's going to allow them to participate in the interactive component. So you can either scan that QR code on your cell phone or go to www.menti.com and enter this code when you get there. And I'll give you just a moment here with this slide, and then I'll move on. This information is also included in some of the other slides to allow the people who are joining a little bit later to catch up with us. All right, I'm assuming that most of you are into our Menti here, so please go ahead and let us know where you're joining us from. Great, definitely. We've got pretty good cross-Canada coverage here. We've got at least one dot outside of Canada, which I will assume means we've got some folks joining us from the US as well, and maybe Europe. There's a dot out there in the ocean, but really nice to see that we're getting people kind of coast to coast in Canada. And, you know, I think the 2023 wildfire season really woke all of us up to how extreme and dangerous this problem can be nationwide. Just a quick question for you to categorize where you work very roughly: government, academia, or other. And I'm trying a new feature of Menti that will allow me to break out results by these categories for one of the questions. I see we've got about 100 people online. We've got more than 70 reading here. I'll just give it a second while we collect a few more answers. But looks like we've got, very strong representation from government or allied government services. And just consider this picture for a moment and think about where and when this event may have occurred. You can see in the background that we have very smoggy conditions. You can see in the foreground that we have a constable wearing a face mask. And you can also see from the background that this is kind of old-timey. So give it a moment, think about it, and then do you know what this event was and where it occurred? Okay, we got guesses coming in kind of all over the world, but most folks are getting that this was in Europe, and indeed it was in London. Next question is, what year did this occur in? Yeah, most people are getting the quite a while ago aspect of this. It was in 1952. And if you're an environmental epidemiologist, you know that this was the Great Smog of London, and it had a marked impact on mortality for about a week in December of that year. And I would call this the initiation of the study of air pollution and health in the world. It sort of kick-started environmental epidemiology in a similar way to the cholera outbreak many years earlier that kick-started the practice of epidemiology in the same city. And I wanted to highlight this event because the environmental epidemiology that we got happened after this event and for decades afterwards has really influenced air pollution. We've used the evidence from hundreds of thousands of studies to bring air pollution from sources that are controllable under control. In this case, it was coal burning for heating. And, now you would find that London operates almost entirely on electricity and probably some gas. And those transitions have really been motivated by the evidence. Now, think about this picture. There's some clues as to where this might be in the skyline there, if you're familiar with it. And where in the world was this? All right, we got most people picking up on the fact that that was in New York. And what year was it? All right, pretty good agreement that it was pretty recent. Indeed, that was last year in New York. And I want to highlight this because that event in London was, a significant long duration air quality event that motivated a lot of change in the decades ahead. This event in New York was really the first time the Eastern Seaboard has been heavily hit by wildfire smoke, but it's a harbinger of the types of conditions we're just going to need to expect across North America and across the world in the years to come. So these very intense, long duration episodes due to wildfires. So the 2023 wildfire season was the most severe on record in Canada. Do you believe there will be a more severe season in the next 10 years? All right, well, lots of people coming in on yes for that one. I'm going to reserve my response till we get to the end of the presentation. You're wildfire folks, you are very familiar with what happened in 2023, but I really do love this plot because it so clearly shows how different 2023 was from the years that came before it. You might be a little less familiar with the total carbon emissions from these fires in 2023. So the gray lines that we have here are the previous 20 years showing emissions by timeline in the bottom axis here, and the dark line is the average of those past 20 years. What we saw in 2023 was a very early start to the wildfire season. We're all familiar with that. And then just this steady climb throughout the duration of the summer. And indeed, when we got to September here, we had the most the most intense slope that we'd had all season. So this season started early and it went and it went and it went. And the total carbon emitted was unlike anything else we have ever experienced before. Now, I told you earlier that I've been studying the public health effects of wildfire smoke for more than 20 years. I did my PhD thesis on the 2003 wildfires in BC. This is the BC wildfires here. And at that time, it was the most intense season we had seen for a long time. There was considerable loss of assets in that season, and, it got a lot of attention. And I just want to highlight that, since then, we've seen a very steady trend of severe and increasingly severe wildfire seasons in the province. This question of wildfire smoke is not going away anytime soon. Pick one word to describe how wildfire smoke makes you feel. Interesting. I did this exercise at a presentation a few weeks ago that was mostly attended by students, and there was a very clear trend towards words like anxious, worried, concerned, nervous, terrified, those sort of emotional responses. I thought this crowd might be a bit different. This is a much more wildfire educated crowd, but I see some excited in there as well, and I know that that there is going to be a different perspective in this group of people. Busy. I hear you on that. Happy, I'm not so sure about that, but it is interesting to see a very similar type of response in a very different crowd. How is wildfire smoke different from other types of air pollution? You can vote on as many as you want to in this one. Yeah, interesting. So really strong votes on no regulatory control. Um, I would say that all of these things are equally true. When we're talking about, the more conventional sources of air pollution in the world, industry and traffic, um, we can expect that these sources emit a pretty steady amount of pollution in very specific locations. Industries obviously don't move. They're a point source. The source gets blown around depending on what the weather's doing. And although vehicles themselves move, the road network doesn't really move. So they're kind of spatially constrained in where they can go. And this is pretty predictable in the scheme of things. We can get pretty good models that show us the more polluted areas of a city, the less polluted areas of a city when we're talking about these sources. But when we're talking about wildfires, they can pop up kind of anywhere. And because they are so weather dependent, those emissions can really go everywhere as well. Now, again, I work in BC. That's my jurisdiction. So everything I'm going to be drawing on here is from BC, but BC is a really good exemplar when we're talking about wildfire smoke, because again, we've had that kind of 2-decade history now of intense and severe wildfire seasons. So this is from a model that we run called the Canadian Optimized Smoke Exposure Model, and it just shows you the number of smoky days between 2010 and 2022 in British Columbia. And what you can see is that we get a lot of smoky days in this intermontane region. And that's not surprising. This is dry and very fire prone, but we do get smoky days elsewhere throughout the province as well. But the real nexus here is kind of around the Prince George area, and then down here along the border as well, and then through this central region too. And I just want to walk through kind of what a few bad wildfire seasons look like in these different places. So this is Prince George, and this is PM 2.5 concentrations on a daily basis. And in here, we've got the extreme 2017 season in blue, the extreme 2018 season in green, and then the 2020 season where we had a late long-range transport event from smoke in Washington, Oregon, and California. So here we can see, 2017, we certainly had some big impacts, but 2018 was a different ball game again. In both summers, the impact has lasted for weeks. And then even though it was a long-range transport event from the south, we still had kind of a significant blip of smoke here in September from that event. If we look at Kamloops, we see quite a different picture. Very strong impact of the 2017 event for weeks and weeks. Similar, magnitude of impact for 2018, but more constrained in time. And then a similar impact in Kamloops as in Prince George for that 2020 event. So, even though these places aren't that far away from each other, really, we see that the exposures that are occurring in them are quite different from each other. And then finally, Vancouver, which is kind of out in that coastal area, and it compared with the rest of the province, it doesn't get a lot of wildfire smoke, but the smoke sure gets attention when it hits Vancouver region. 2017, these impacts were pretty moderate. We had kind of this big bolus of smoke in 2018, and then we got hit similarly hard by that long-range transport event. So smoke is really different in different places, and even if they're not that far apart geographically. Which component of wildfire smoke affects our health the most? Yeah, we're settled on fine particulate matter as the first place, and the gases are kind of having a bit of a tug of war down here. Honestly, we don't really know. If I had to hazard a guess, I would say fine particulate matter does affect our health the most, probably organic gases after that, and then the inorganic gases. But it's a challenging thing for us to study. When we're talking about the air quality impacts of wildfire smoke, it really is PM 2.5 that changes the most of the stuff that we regularly measure. But we don't regularly measure organic gases. They're really hard to measure. We don't have near real-time instruments for them. We do get samples of these gases at different stations across the country for 24 hours once every 7 days, but we just don't have nearly as much of a handle on that organic gaseous component as we have on the other components. And, wildfire smoke is super complex. I like this image because it shows you've got the flaming front of the fire, you've got smoldering fire. We're gonna have different smoke coming out of those flaming and smoldering components. The degree of completeness of combustion is a really important part of what the smoke mixture looks like. And you could go to this fire and take a sample, here, and then take another sample an hour later here, and you're probably going to find that what you get in that sample is totally different on a 1 hour basis. It depends on the fuels, it depends on the temperature of the fire, it depends on the meteorological conditions. And then more and more, we are having wildfires turning into interface fires. And that means that not only do we have wildland fuels contributing to the smoke, but we also have anthropogenic fuels contributing to the smoke. And in the case of a large interface fire, like something like Fort Mac, we know that just totally changes the smoke profile. But primarily, the things that we need to keep in mind is that wildfire smoke is composed of very fine particles. Now, we talk about fine particulate matter less than 2.5 microns in diameter, and that's kind of these pink balls on this hair. But in reality, what's inside those very small particles is these little soot balls or tar balls that kind of stick together. And the implication of that is we have a very high surface area to volume ratio for the tissues of the body to interact with. It's quite different from having just a one round sphere to have all of those little things clumped together. And that's one of the concerns that drives the health impacts of wildfire smoke. At the same time, we have these primary particles that are being emitted from the fire, and then as they travel through the atmosphere, they are aging, they're making secondary organic aerosols. The VOC and NO2 components are volatilizing or changing to ozone. The volatile organics are volatilizing. So the smoke is aging as it moves away from the fire. And that aging process also contributes to its downwind toxicity. Very, very complex compared with our other sources of pollution. Now, when we're talking about fine particles, the concern for us is that these particles penetrate very deeply into the lungs. So at the end of your lungs, you have what are called the alveolar sacs, and that's where the oxygen exchange happens. And two things are going on here. First, your body does not want these particles in the alveolar sacs, and it is going to mount an immunological response against them. Just like it doesn't want a virus or a bacterium there, it is going to send out T cells and all of that stuff to get rid of those particles. But the immunological response can't keep up. The particles aren't alive. They can't be neutralized. And what that leads to is not only irritation from having the particles there, but inflammation from that immunological response going a little bit haywire. And that inflammation can affect your lungs and then affect your entire body. At the same time, the very small particles, the ones that are less than 1 micron in aerodynamic diameter, can translocate across the lung at these alveolar sacs into the bloodstream. And that means that they have access to every organ system in the body. So there's not only just this direct effect on the lungs, which I think everybody understands, but wildfire smoke is going to affect your heart, your brain, your kidneys, everything that's going on in your body, the wildfire smoke is going to affect it. And we know from years and years and years of research on air pollution more generally, we can see these effects. This is a statement from the European Respiratory Society and the American Thoracic Society some years ago now, but it hasn't changed, where they were just pointing out the places where we have strong evidence in bold and suggestive evidence, not in bold, of the effects of air pollution on human health. And you can see it affects the brain, it affects the lungs, it affects the skin, it affects the endocrine system, it affects the reproductive systems, and it affects the heart. So these are whole body exposures, and they can affect everything that's going on in you. How many hours of wildfire smoke exposure are needed before someone can experience extreme health effects? And I mean like a heart attack or an asthma attack. Yeah, so, it's less than an hour, probably, based on everything that we can tell. This is research done by my prior PhD student, Angela Yao, but she was looking at ambulance dispatches in BC. And ambulances are super handy because we know exactly what time they got dispatched, and we know exactly where they got dispatched to. So we can, estimate the smoke exposure at that location at that exact time. And she looked at the effect of smoke exposure over 48 hours. And what she found when we're talking about ambulance dispatches for breathing problems and paramedic assessments for breathing problems is that the highest risk was in that first hour, and then the risk declined over the next 48 hours. Now, when you accumulate the risk over all of the hours, you can see it becomes significant after 48 hours. But what this is telling us is those events were happening pretty immediately. Here is a math question for you. If there are 10 respiratory emergency room visits on a day when the PM 2.5 is 10 micrograms per meter cubed, how many are there on a day when the PM 2.5 is 100 micrograms per meter cubed? Looks like we maybe have some air pollution epidemiologists in the crowd here. Oops. So on average, on a smoky day like this, I'm going to expect about a doubling of all respiratory effects in the province of BC. And this is something that is not intuitive for people. I think, and understandably so, unless you kind of know about this, you would assume that the risk is linear, and that if the air quality is 10 times worse, it is 10 times worse for your health. But that's actually not how it goes. So again, these are data from British Columbia showing asthma-related physician visits, so people who went to go see a doctor because of asthma, and dispensations of Ventolin, so the kind of blue puffers people with asthma might use, across concentrations of PM 2.5 in the province. And, we have some very high concentrations out around 300 micrograms per meter cubed here. And what we see in both cases is a very steep climb to about 50 micrograms per meter cubed, and then things start to flatten out. And when we accumulate all of the events that occurred within these different PM 2.5 concentration ranges, we see about 50% of the burden is due to concentrations less than 50 micrograms per meter cubed. Another 30% of the burden is between 50 and 100 micrograms per meter cubed, and only about 20% of the burden is at these very high concentrations. First of all, these low concentrations happen a lot more often, and second of all, that relationship is much steeper in the low end of the concentration range. However, and this I'm just estimating based on my own experience, most of the attention is on these very high concentrations. If we don't start talking about wildfire smoke until it hits 100 micrograms per meter cubed, we have lost 80% of the burden, and we're only talking about 20% of the burden. So it's really important to understand this curve when we're talking about public health protection and worker protection. Now, this is, again, out of BC, but it's just kind of what happens on a smoky day. So at 100 micrograms per meter cubed, what do we expect to see? On the left-hand side, we have respiratory effects, and on the right-hand side, we have cardiovascular effects. And the blue dots are dispensations of medications for these conditions. The red dots are physician visits for these conditions, and the black dots are deaths due to these conditions. And pretty uniformly, in the respiratory side of things, we see sort of an increase between 150 and 100% across all of the respiratory outcomes. Some of these are not statistically significant, but overall, the dots kind of line up along the same line. When we look at the cardiovascular outcomes, we see that the magnitude of the effect is much smaller. It's still a significant effect, but it's quite different from the respiratory effect. And this is very consistent across the global literature. And one thing that it's telling us is that people with respiratory conditions are very sensitive to wildfire smoke. And that might be because of the particles, but it might also be because of the co-pollutants that those particles travel with that we don't do a great job of measuring. Again, those volatile organics that we don't have a network out to measure, so we know they're there, but the PM 2.5 is standing in as a proxy for a much more complex mixture. I don't want to go through everything we know about the acute effects of wildfire smoke. I showed you that statement from the two big respiratory societies, and this is how I like to summarize it. There are some ways in which the evidence on wildfire smoke is very consistent with the evidence on air pollution from other sources. It seems to affect every organ system in the body, and there's more and more evidence coming out about this all of the time. And the magnitude of the effect is similar for most outcomes. So the cardiovascular effects associated with wildfire smoke are pretty similar to the cardiovascular effects associated with air pollution from other sources. The big difference here is the acute respiratory effects. There is a stronger acute respiratory effect, especially for people with obstructive lung conditions such as asthma and COPD. So those conditions where your lungs want to close up, they get irritated and they close. And, we really see the impacts of wildfire smoke on those people. Now, the question we are all tackling, does wildfire smoke affect our health even after the air has cleared? Yeah, so we got a bit of balance here between yes and somewhat fewer for probably, and that's about where I would sit on this as well. We don't have enough evidence at this point to say, yeah, wildfire smoke exposures are exactly the same as air pollution exposures from other sources. We're not there yet, but we are generating more and more evidence about what happens in places that are exposed to extreme events or exposed repeatedly to different events. And when we think about this, I like to think of Kamloops in the summer of 2017 as an excellent example. So, again, we had this long, prolonged, very intense smoke season in Kamloops. And if we calculate the annual average mean concentration of PM 2.5 in Kamloops without that event, it's 7 micrograms per meter cubed. If we include that event, it's 15 micrograms per meter cubed. So that smoke season doubled the long-term average in this region for that year. The US EPA would consider any change of 0.2 micrograms per meter cubed annually as a change that was relevant to the health of the population in that region. So a doubling is, significant. And there are every reason to believe that, after this smoke goes away, it's going to have health impacts that continue into the near future and maybe into the distant future. However, we know a lot about air pollution in urban environments. We know that living in a more polluted city means that you'll have a higher risk of chronic disease and that you will have a shorter, or you're likely to have a shorter lifespan than if you don't live in a polluted city. But air pollution from wildfire smoke, again, is really different. Polluted cities are polluted all the time. That pollution kind of goes up and down depending on the weather conditions, but it's day in and day out, year in and year out. Wildfire smoke, on the other hand, you get this big events maybe, and then you might get, 2 years of no wildfire smoke that's going to give your body a chance to recover from those exposures. On the other hand, the exposures that occurred may have been way higher than you would get in a polluted city. So this difference in the exposure profiles might make a difference in the population health outcomes. And that's what we're all kind of really focusing on and working on these days. However, this is what I can say based on the evidence to date. The chronic effects so far, persistent reductions in lung function that last for years post-smoke exposure. We are now getting evidence of increased cardiovascular disease in wildland firefighters, which is consistent with what we would see in structural firefighters. Higher healthcare use in the population post-wildfire, higher rates of infections in populations post-wildfire, subsequent severe events, so higher risk of having a heart attack post-wildfire. Mood and developmental disorders, very hard to disentangle the smoke and the wildfire here, but we definitely know that these events impact people's mental health. And then increasing, very small amount, but increasing evidence that these exposures may be associated with lung cancer and brain cancer. So really what I'm saying right now is, in the absence of more specific evidence, there is no reason to believe that exposure to wildfire smoke carries less risk than exposure to other types of air pollution. I want to spend a little time here talking about a very specific population, because I think this is really important when we're thinking more broadly about the health effects of wildfire smoke. And that is the intersection of critical windows of human development and very high smoke exposures. So what does it mean if you're pregnant and it's really smoky outside? If you're neonatal and it's really smoky outside? If you're born and your tiny baby lungs hit wildfire smoke in that first month of life? If you're a toddler, what does it mean? And that's a really important question, because these exposures have the potential to do damage that is lifelong. So, they can knock down the health of an infant and affect their health trajectory throughout their life course. So we did a study on infants that were in utero in BC in 2016 through 2019. And sorry, I'll just go back here for a second. 2016 and 2019 are the gray line and the black line. These were both lower than average wildfire seasons. And then 2017 and 2018 were extreme wildfire seasons. So we have that really nice contrast in this group of infants who were prenatally exposed. Now, why do you think children are at more risk than adults from exposure to air pollution? At higher respiratory rate, they breathe fast, rapid lung development, stuff is, mutating, or not mutating, but cells are splitting very quickly. They spend more time outdoors and they're more active outdoors. Yeah, I think this is how I would pretty much sort them as well. I think rapid lung development is the most important thing. We have tissues that are growing really quickly, and there's a lot of opportunity for these exposures to disrupt that development. At the same time, we have a high oxygen demand to support that rapid growth. So there's more exposure due to that high oxygen demand. This is true for people who are pregnant as well. And then in the lesser places, these other elements behind exposures. So this is looking at that group with respect to preterm birth, very preterm birth, extreme preterm birth, and stillbirth. So, if we're talking about severity, the severity here is going this way, where stillbirth would be the most severe, and extreme preterm birth is a very severe outcome as well. This is weeks spent in NICU, and a very, the chances of survival for an infant born this preterm are not great. And what we see here is overall the blue dots, there's sort of this increasing risk in terms of preterm birth severity, and the preterm and stillbirth are quite similar. But when we split this out by year, where the green dots are the 2 severe wildfire seasons and the red dots are the below average wildfire seasons, we see totally different patterns. So in these severe wildfire seasons, we're seeing, these strong associations between, preterm birth, very preterm birth, extreme preterm birth, and that's getting stronger as we go. And then, we don't really see those associations for the below average wildfire years. This is work from my PhD student, Emma Cox. And this is work from my PhD student, Jeanette Len, who's looking at preterm exposure or prenatal exposure and infections in the first year of life, and antibiotic-treated infections in the first year of life. We really don't want kids to have antibiotics in the first year of life. It really kind of messes with their system and puts them at risk for conditions such as asthma and allergies and what have you. So this is an important consideration. And on the top here, you can see the exposures between the 2 different groups. Obviously, in those 2017 and 2018 seasons, we had a lot of wildfire smoke. And below here, you can see the rate of diagnosis for otitis media, or inner ear infection. And, I call this eyeball epidemiology. You can see that the red lines and the blue lines are different. But when we look at this according to windows of prenatal development, we do see different patterns across those windows. I'm going to come back and talk about this protective effect later, but I want to focus here on this effect in the other direction. So, we're seeing that there's a higher risk of antibiotic-treated otitis media by age 1 year for those who were prenatally exposed in this 4th window of lung development, which is pretty consistent with the 2nd trimester. and it drops down a little bit in the window that's consistent with the third trimester. Now here we see that wildfire smoke protects infants from having infections. And what we hypothesize, and I'll tell you a little bit more about this after, is that actually wildfire smoke might be associated with a pretty strong effect on pregnancy loss in the first trimester. We can't measure that because the data that we're using rely on a registry that only starts in week 15. But we do believe, based on other things that we're seeing in the data as well, that these exposures really probably interrupt many pregnancies. And that's quite consistent with what was found in Southeast Asia during the 1997 to 1998 haze event. So that was a strong El Nino cycle. They had a very bad haze event that lasted for weeks in the region. And what this researcher found was that the more smoke pregnant people were exposed to during their pregnancy, the lower the cohort size. So overall, they estimated that haze event reduced the population of children born in Indonesia that year by almost 2%. And then finally, I want to focus on an ongoing episode or an ongoing thing that's happening in California, where we have these research monkeys at UC Davis. They're kept outside and they're born in the summer, and therefore they keep getting exposed to wildfire smoke because California is quite similar to BC in terms of what's happening in the wildfire regime. And this was from the 2008 event in California. So they had these neonatal monkeys who were exposed to smoke, and then they've been able to follow them for years now because these are quite long-lived animals. And what they found was that the monkeys who were exposed neonatally compared with other cohort that was not exposed, their lungs never grew as big as the unexposed monkeys, and their immune function was dysregulated throughout their lives. And then they followed the offspring of these exposed monkeys. And even though the offspring themselves were not exposed, they found that the immune function of the offspring was also dysregulated. So there was a genetic transmission of the smoke exposures in the parents to the offspring. So I hope I've convinced you that smoke exposures are not benign by now. And we have to start thinking about how do we protect people from these exposures. So what do you think are the best ways to protect people from the health effects of wildfire smoke? I think you get up to 3 choices here. All right, well, we're certainly getting consensus around indoor air filtration, which is certainly my favorite of these choices, but they all have a role to play, and that's one of the complexities here. Within Canada, if you're not running an indoor air filtration system of some kind, staying indoors may reduce your exposure and it may not. These are data from houses in Williams Lake and Lytton area in the summer of 2003. So back to that season, done by someone who was also a student with me at the same time, Prabjeet Barn. And the black lines show the infiltration into the homes when there was no air cleaner running. And you can see here we have 100% infiltration of the smoke into the home. And it really just kind of differs according to the houses. It will depend on the features of the building envelope and the way people behave in that environment. But when we turn air cleaners on, these gray bars, in almost all cases, there's these very significant reductions in the indoor PM 2.5. We've also, figured out that these very cheap solutions also work really well, and they have the advantage of the fact that they're non-proprietary. You can always find a square furnace filter and tape it to a fan, whereas if you buy something like this and the manufacturer discontinues making it and making the filters, you've got an expensive piece of garbage on your hands. I'm a huge fan of monitoring indoor and outdoor air quality. We're now in a place where we have low-cost technologies that do a pretty good job of this. I mean, they're obviously not the really expensive government instruments that we have, but they're pretty great. And they provide information. There's no reason not to have these technologies. You can have things that you can carry on your person that connect to your phone. You can have things that sit on your countertop at home. And, they really do provide great information about the PM 2.5 that people are being exposed to, and therefore some information about that whole smoke mixture. This is a map built by Braden Nielsen, who was at UNBC and is now at ECCC, that's bringing together data from all the low-cost sensors that are publicly available across Canada and showing them along with other information. In this case, these are estimates from the firework forecast. So, when we have these low-cost technologies available, we can get a lot more information than we have if we just have that, very skookum high-end air quality monitoring network from ECCC and other partners. And more, we're seeing the utility of smoke forecasts. Fireworks now running out to 72 hours. It is performing very well. We're seeing, this is a news segment where someone's reporting on the smoke as part of, normal Weather Channel operations during this 2003 event in Eastern North America. So, this can really provide us useful information with what's likely to happen over the coming days. Reducing activity outside, I would say, falls under the category of common sense rather than evidence-based. But if you consider, if you're out for a run, and you're running hard, you're breathing 10 times more air than you are if you're resting. That means you're breathing 10 times more smoke if you're outside, and you're breathing it deeper into your lungs because your respiration is so deep under those conditions. So, moving this indoors or taking it easy on these smoky days can really go a long way to reducing exposures. And then there's the education component of this. We've worked hard on this at the BCCDC to put out information for people. How do I prepare for the wildfire season? If I live in a fire-prone area, what if I'm pregnant? What should I be considering during the wildfire season? This is another important piece of the puzzle. What else do you think we can do? Oops, sorry. I meant to scroll down. Yeah, we're seeing ideas from across the spectrum. How do we reduce emissions from source? What role does prescribed fire have to play in that? How do we identify those people who might be most at need? Do we need to consider moving to other places? What role is there for community clean air shelters? All of these things kind of need to be on the table. There's no silver single bullet way to reduce wildfire smoke exposure. It's many different ways together. And I'm getting towards the end here. This is something, I struggle with a lot. On one side of the equation, there's lots of people who like to say, Wildfire smoke is not dangerous. It's natural. It's fine. And on the other side of the equation, there are people who want to panic about wildfire smoke and they call it unsafe. I don't think either of those is true. There's a few people for whom wildfire smoke exposure may be unsafe, people with very reactive asthma or very reactive COPD. But for the vast majority of people, it's a form of air pollution that can affect your health. The more you reduce your exposure, the more you reduce your risk. And it really is kind of that simple message that's necessary and that I encourage all of you to carry into the summer ahead of us. Final, oh no, maybe second to last, final question. What source of air pollution do you think has affected your life the most? Yeah, I know we've got frontline people on here, fireys, as you would be called by my Australian colleagues. So lots of people saying wildfire smoke as one of the most important sources of air pollution in their lives. Some folks who are heating with wood stoves and what have you. But if you do work in wildfires and you do have smoke exposures because of your work, I really encourage you to be aware of those exposures and, where possible, to take measures to reduce those exposures. And I know you're going to be hearing from kind of the wildfire community on this issue in the weeks ahead of the February flare up. We are moving to a place in North America and other parts of the world where wildfire smoke is starting to dominate people's lifetime exposure to fine particulate matter. This is from the US, but I'm sure Canada looks pretty similar, comparing the number of smoky days in 2009 to 2013 with those in 2016 to 2020. And you can see the map is getting more purple all the way across the board, but especially so in the western side of North America. And as we bring our other sources of emissions under tighter and tighter control, vehicles, industry, we've had really good gains in reducing emissions from those sources. This is becoming a bigger and bigger and bigger contributor to our lifetime exposure. And it really is the exposure of the future. This is really important for us to pay a lot of attention to at this point in air pollution and epidemiology and in public health. And I want to just go back to that image of London on that day in December of 1952. That was a spatially constrained event. It affected the city. It certainly affected a very large population, but this is a smoky day in 2020. And what we have is hundreds of millions of people being affected by very poor air quality. And that's the difference, the key difference, I would say, between wildfire smoke and other sources of pollution. The degree of impact and the geographic scope of impact is really extraordinary. So, does Sarah believe there will be a more severe season in the next 10 years? This is a strong maybe for me. 2023, as evidenced by those first figures I show, really was something extraordinary. In some ways, it doesn't matter. The only sane way for me to do my job well is to believe that next season's going to be worse than last season. That's the only way that we can continue to move forwardness on public health preparedness and public health protection. So I don't care what 2024 is going to do. I'm going to approach 2024 as if it is going to be as bad or worse than 2023 was. And this is from a few weeks ago now that the situation has changed a little bit. because of the weather here, but it's just an indicator that we might be in for another rough season in BC in 2024. This is, accumulated snowpack across the province, and this is the time series of that snowpack in the year to date. And you will see that it is sitting below all of the other years being considered in this analysis. So we are not out of the woods yet. It is still dry in the province, and that continued drought is likely to affect our wildfire season again. So that's what I've got for you today. I see there's a lot of stuff going on in the chat. I'm going to stop sharing my screen and welcome any questions.
Thank you, Dr. Henderson. That was really great. Lots of thank yous coming into the chat. Just going to adjust my screen here so I can see better. So we've had a lot of discussion, as you can see in the chat. The first question that came in from someone who is a forest firefighter for the government of Ontario. And they've acknowledged that their government is still teaching them to use bandanas and face coverings on front lines. Is this at all effective? And what does the scientific evidence say?
Yeah, and I will make the strong caveat that I am not an occupational health person. I am a public health person. A bandana does not do anything. It may make people feel like they're doing something. It may give a false sense of security, which is not a great thing, but it is not designed to filter the particulate matter or any of the gases in wildfire smoke. So that's not an effective occupational health intervention. And I know there's going to be lots of people on here who will be able to talk about more effective interventions, but I'm very happy to say, no, that's not good enough.
Thank you. So in week 3, we're going to have Dr. Paul White talking about some exposures more specific to structural firefighters, but there is some overlap. And then in week 4, we're going to have a plethora of people actually coming to us from the BC Wildfire Service to talk about some of their current research. And this is one of the things that's ongoing. So join us in week 4. There have also been some people here posting that studies are being done currently in New Zealand. I believe there's one going on at the University of Toronto right now, and they've included contact information. So if anyone wants to reach out. All right, I'm scrolling back up to the top. So we're getting a bunch of questions about masks. Are you comfortable speaking about masks with regard from a public health perspective, Dr.
Absolutely.
Henderson? Okay. Yeah. So this question is specifically looking for epidemiological evidence. If there's different age groups in the pediatric population that are vulnerable to PM 2.5, for example, 0 to 4, 5 to 12, and the efficacy of masks, I believe.
Okay. So, I would say the older kids get, the less vulnerable they are, but until your lungs are fully developed at the age of 18 or so, there is still development and growth of the lungs happening. So there is risk across the entire childhood spectrum. But as kids are getting kind of more into the 10, 12, and they're on their way, I would say that risk is starting to reduce. In terms of children wearing masks, now, there's not a lot of evidence on this, but here's the thing about masks. So we know that something like an N95 respirator will be very effective for reducing fine particulate matter exposures if it is well fitted and well worn. The moment you take it off, it is not doing that. The moment it is not well fitted, it is doing a much poorer job at doing that. And expecting kids to wear a well-fitted respirator for long enough to truly reduce their exposures and have a health impact, I think it's a big ask. So it's not that, masks don't work. In the lab, when you can tape them to a mannequin, they work great. In the real world, where you got kids running around outside and doing what they want to do and itchy noses and all of that, the real world efficacy is very likely much different. So I would, I think there's a role to play for masks in the public health response to wildfire smoke, but it cannot be our primary way of tackling this. The vast majority of us spend the vast majority of our time inside, and we really need to focus on air quality in the indoor environment as the primary tool for reducing exposures for people.
Perfect, thank you. The next question is regarding if you believe that the lack of publicly available air quality monitoring stations outside of big cities could lead to more adverse health effects in rural or remote areas.
You know, I think it leads to less awareness in rural and remote areas, and that less awareness may translate into poorer health outcomes in those regions. We're moving to a place in Canada where, there's going to be implementation of something called air quality on the grid, which means that we're going to have information across the country about the air quality circumstances rather than at these discrete locations where we have monitors placed. And I think that's going to be a game changer when it comes to communicating about wildfire smoke and risks in regions that currently don't have good air quality monitoring. In the interim, I, again, can't say enough about the value and utility of low-cost sensors like Purple Airs or air quality eggs. And that map that I showed you from Braden Nielsen, the more of those we have out there, the better the information we have for everyone.
Thank you very much. That was also noted by one of our attendees was, we get broader coverage by using things like IQ Air or Purple Air. Okay, so there was a lot of compliments on the presentation. So this is a statement and a question. So in the US, air quality has improved much over the country since the Clean Air Act, but there's pretty solid research showing opposite trends in the Western US because of bigger fires. Is something similar happening in Canada? Are the NAPS data long or dense enough to detect any changes yet?
That's a great question. I don't know for sure. I would hazard a guess that we're seeing very similar trends. And even, the air quality in Canada has always been quite different from the air quality in the US in many regions. So I'm not sure whether or not people are working on addressing this question, but if we were to take air quality as measured by PM 2.5 in Western Canada over the last 30 years, I think we'd be seeing this kind of growing trend towards more PM 2.5, and wildfires would be the only thing driving that trend.
Thank you. There's a question if you know of any sound epidemiological studies linking wildfire smoke exposure and cancer risk.
Sound. So this is a challenging thing to study epidemiologically. There's one good study out of Brazil where obviously we're talking about a different kind of smoke because we're talking about primarily Amazonian type fuels. And we do know that the fuels matter, but there's strong evidence from that study in Brazil. And then there's a study in Canada that I would say is moderately strong evidence. So the researchers looked at proximity to wildfire, lung cancer, and brain cancer, and did find those associations with proximity to wildfire. They didn't look specifically at smoke, though. So I would say that's the next step for the Canadian evidence, is to look at that smoke exposure rather than kind of wildfire proximity exposure. But chances are that smoke would be the underlying factor. Of course, it could also be stress and other pathways that might lead to cancer. But it's a good study and it's well done. It just didn't use specifically a smoke exposure.
Thank you. There's one more question regarding bandanas. This person would like to know if you're aware of any differences in bandanas with charcoal inserts. They seem to see a lot of these floating around or being marketed to firefighters.
I've never heard of a bandana with a charcoal insert. Here's what I can tell you. I spent a long time thinking about masks during the pandemic. I was redeployed to COVID-19 for almost 16 months, and a lot of the work I did was on masks. And a lot of that actually translates quite well to smoke as well. A well-fitted N95 respirator is the thing that will reduce particulate matter the most. a well-fitted surgical mask where, you know, there aren't gaps around the face and it really is the air is going through the mask and not around the mask is pretty good too. It's not quite as good as an N95, but it's pretty good. And then a 3-layer cloth mask where you have different types of materials, where you've got maybe cotton and silk mixed, something that has kind of an electrostatic property in it, is also really good. The key feature or the key thing to consider in all of these types of masks is fit. It has to be well fit to work. The air has to go through the material and not around the material. So, you know, if we're talking about charcoal inserts in a bandana, if the bandana is just hanging off your nose, like I don't know what this looks like, but if the bandana is just hanging off your nose, it's not doing anything. And certainly a single or double layer of cotton that I associate with a bandana is not going to be useful, kind of charcoal filter or no.
Thank you. We have a question from a fire crew in one of our national parks. You mentioned the difference between the effects of old smoke and new smoke. What hazards does new smoke pose compared to old smoke? Are there differences in particulate size?
Yeah, okay. Again, this is not a place where we have a ton of evidence. We do know that smoke ages in the atmosphere and that the size distribution of the smoke changes. The particles get larger kind of as they stick together, but it's not a really big shift. The distribution just sort of shifts to the right a little bit. So there is a change in particle size. There's also a change in particle composition. And what we see is that the aged smoke particles seem to have more oxidative potential, meaning that they can, you know, take more oxygen from your body when you inhale them, and that leads to what we call oxidative stress, which is one of the primary mechanisms by which fine particulate matter harms human health. Having said that, it's not like the particles at the other end don't have any oxidative potential. They also have oxidative potential, and the exposures closer to the fire tend to be higher because of diffusion and dispersion. So it's a bit of a mixed bag. Probably the aged smoke is on average somewhat more toxic than the fresh smoke when we're talking about the particles themselves, but you're exposed to a lot fewer particles because the smoke is a lot further from the fire, whereas you have a much higher particle exposure closer to the fire. So I've often said, like, I'm not gonna get to a place in my public health practice where I'm like, yeah, fresh smoke, no worries. Aged smoke, worry about it. Like, smoke is smoke is smoke, and none of it is good for your health. And there are some subtleties about those implications depending where the smoke is in its life cycle.
Thank you. So many variables to consider, and also, you know, we may consider ourselves in wildland fire, but like you said, those interface fires are becoming more and more common as well, which is introducing a whole different kind of fuels and chemicals and stuff into the mix. One person would just like to say, as a parent, they applaud your realism in this argument. They see the opportunities to improve indoor air quality systems, and thank you for that.
Yeah, you know, I'm just gonna make a real big plug here for cleaner indoor air in schools and daycares. Like, these are places where children spend a lot of time, and focusing on the indoor air quality in that environment is going to be such a bigger win than this idea of maybe kids wearing masks to protect themselves.
I very much agree. So this is a public question. If you are an organization offering outdoor recreational programming and you need to develop a weather policy, including a cancellation policy addressing air quality forecasting, at what point do you decide to cancel the program? Do you have any insight?
Yeah, so this is a question I deal with quite a lot. I absolutely encourage anyone who's planning events or outdoor activities to have a smoke contingency plan the same way you would have a rain contingency plan. It's a type of weather, and you should have some idea in advance of how you intend to handle that event when it's smoky. I'm not going to say there's a threshold at which you should make changes. Again, I showed you that curve. A lot of the effects of smoke are in those lower concentrations, but you should be thinking about who's at this event. Is it an event for small children with asthma? Well, then I'm going to suggest you cancel it. Is it an event for healthy adults, without significant chronic diseases? Then you're probably going to be okay. Most people will be quite resilient to the exposures. Is it an event for elderly people with COPD? Cancel it. So you have to think about who's there, what they're going to be doing. Is it a marathon for children with asthma? Don't do it. Is it a croquet game for adults with no comorbidities? Probably going to be fine. You really just have to think through what your event is, who might be at risk, why they might be at risk, and what the options are for reducing those risks if it's smoky outside.
Thank you for that. I have one last question here. I'm guessing it's outside of your wheelhouse, but I'll put it to you anyways. One person was wondering if you have any information regarding the difference of smoke from peat fires. So kind of that fuels is important question.
So fuels is important. We have peat fires, we have fires in Australia that are primary eucalypt, some fires in California. We have hardwood fires in the east, we got softwood fires, and in the lab, these things make a difference. The toxicological profile of smoke from different fuels is different. Peat fire is among the more toxic of the fuels. Pine is also quite toxic. And in my way of thinking, which is very unsophisticated, eucalypt is also quite toxic. These oily trees with a lot of resin, and the complexity of that fuel does seem to produce a more toxic kind of smoke. Having said that, I'm never going to say, well, we shouldn't look to evidence from peat fires if we're talking about lodgepole pine fires. Again, smoke is smoke is smoke. These are coming from wildland fuels or from fuels on the landscape, and there's something to be learned from them, but there may be these subtle differences in what we find depending on the source emissions.
Well, thank you very much, Dr. Henderson. I know you have a commitment that you need to get to. So with that, I will let you have any last comments that you have, and then we'll turn the table over to Brian Wiens to talk about smoke models and forecasts.
Yeah, thanks everyone. I haven't paid attention to the chat at all. It's time on my laptop and it's very tiny and I'm not wearing my reading glasses, so I can barely see it. It's been very nice to chat with you. Thank you very much for interacting with the presentation. I wish I could stick around, but I gotta go teach right now. So good luck with the rest of the February flare-up, and I encourage you all to expect another severe wildfire season in 2024, but to hope for something better than what we all experienced together last year. Thank you.
Thank you very much. Bye, Dr. Henderson. Hi, Brian. I see you've got your camera on. So if you need a moment just to get your slides connected. And thank you everyone for interacting so well in that presentation. I hope everyone found some value in it. I know it's a bit of a more general public health perspective, but a lot of it applies for firefighters as well. Whether or not it applies directly on the fire line, most of us have families or friends that are perhaps living in communities that are experiencing smoke, even if we're in a location that isn't. So I think it's valuable for all of us. So we're really lucky now to have a second presenter today. So we have Brian Wiens, who is the Managing Director of Canada Wildfire, and he's going to talk to us a bit more about smoke models and smoke forecasts. So Brian, I'm going to hand it over to you.
Excellent. Thanks very much, Karen. Before I start my slides, I just sort of want to also jump in there and say how much I enjoyed Dr. Henderson's presentation. I've had the privilege of working on and off and encountering her a number of times over the last 20 years as we both sort of wandered through a variety of different worlds in air quality. And I never failed to learn a whole ton of stuff, and she does such an excellent job of presenting it. So even though she's gone, thanks very much, Dr. Henderson. Okay, so what I want to talk about today, and I'll probably be a little bit broader than sort of what was advertised, but is that I'd like to talk a little bit about smoke, sort of what do we know about information, and Dr. Henderson's covered some of this a little bit, so some of this will be a repeat, but it's a thing of interest to a lot of us, and so also want to try and talk about some of the tools that are available to us. So I can get my slides to advance. So I actually have 4 questions that, although I'm not going to address them perfectly in the same order, I will sort of wander through them. And some of it you've already heard here before, which is good, but I'll just do a quick sort of review, if you like, of what comes out of a fire. And so when we're looking at what's actually in smoke, if we're using it to flavor our food, there's certain flavors and certain things that we want it to have, but all fire is going to produce CO2. It's going to produce a certain amount of water. Depending on how oxygen starved it is, it's probably going to produce a certain amount of carbon monoxide. It's going to produce a whole ton of VOCs, and it's going to produce a lot of chemicals in the fine particle world, as noted already. And included in that is a number of the flavor or the smell kinds of things that we actually appreciate when we're sitting around a campfire and enjoying the scent, or when we're smoking ribs or something else on the barbecue. But ultimately, the fine particles, as noted already, is it's a very broad category. It covers an awful lot of things, but it actually is also a very good indicator of fire. So it's probably the single easiest to follow if we're trying to figure out what's going on with the fire. Now, where that smoke actually goes, how it actually gets into the atmosphere, is extremely important for what's going to happen with us. And I've just got a couple pictures here to show different ways that smoke is going to actually enter the atmosphere. So there's a plume on the bottom left, or on the left of your screens there, where the smoke is basically rising up out of the valley where the fire was going. And it's approaching the level at which you have the clouds. And so it's starting to interact with this for the ambient meteorology to some degree. In the center, we have towards the end of the day where the fire was actually dying down a little bit, it was cooling off a bit, and the smoke is starting to hang much closer to the surface. It's lingering, it's not being injected as far into the atmosphere. And then on the right-hand side, actually, we have another plume where it's actually rising and interacting to the point where it's actually creating that cap cloud, or that circle of cloud around the top of the plume, or a pileus, if you like, as that smoke is interacting with the environment around it and actually injecting smoke a fair ways upwards in the atmosphere. And so if you're going to predict where it's going to go, you got to know where it starts. As noted before, there's a number of different air quality networks around, and most of the real-time networks, particularly the government-run ones, are provincial. There was some comments earlier about the National Air Pollution Surveillance Program, or the NAPS program, which is it isn't super dense, but it's very rigorously maintained. It's very sophisticated instrumentation. It's got a broad range of chemistry that's actually analyzed there. But real-time networks have tended to be provincial up until fairly recently. And a lot of them were originally started as a network, as a way of making sure that we were in compliance with sort of what was known about health exposure, or sometimes there was industrial requirements that if you were a plant releasing pollutants, you had to actually demonstrate that the air that was hitting the neighborhoods downwind of you were not being significantly affected. The other thing that's really emerging right now is some of the private networks, or the private providers, and we've already heard about the AQEGs, we've heard about the purple air, and those are absolutely amazing kinds of things. They tend to be focused, or they're probably most commonly focused, on PM 2.5, which is a really good thing if you're trying to track smoke. Air quality is reported, and again, this is going to be not new for a lot of you, but I just wanted to cover it very quickly, that there's basically 2 broad ways that we talk about air quality that is reported, what's actually currently being observed. And one is where we'll measure a number of species. The most common ones that are measured for air quality and human interactions are PM 2.5, ozone, sulfur dioxide, nitrogen dioxide, or nitric oxide, NO2, and carbon monoxide, all of these which are of concern from a health perspective. And one of the ways to report them is say which one's the strongest contributor to the air quality decrease right now, and that's the one we're going to report on. And so basically you say, big problem today is PM 2.5, that's going to drive the entire air quality, and so then you come up with that option. The other option, the other approach to it, is where you actually say, no, we actually know sometimes fairly solidly, sometimes it's a little bit speculative, but that cumulative amounts or accumulation of different species actually gives a stronger health effect. And so the Air Quality Health Index, which is commonly used across the country and is forecast by Environment Canada, is basically looks at PM2.5, looks at ozone, and it looks at NO2. And those three were chosen by using the NAPS network to come up with an index, and it's scaled basically from 1 to 10. Now that development, and it's important to note this, was focused not to include or focused to exclude unusual PM events. And so there is actually, in the original formulation, there is no fire smoke in there. It's basically just a relationship between these pollutants and health outcomes. And so it is a way of reporting, and it's the intention is it gives people a 1 to 10 kind of number, and entirely focused on, is there a higher risk or a lower risk? And as noted, several of Dr. Henderson's replies, that's going to be different depending on your sensitivity, on your sort of health situation, but it's intended as a tool that way. So if you go across Canada, this is I think all the real-time networks that we actually have reporting some collection of the air quality, standard air quality species. And so there's a fair number, and as noted in one of the questions, though, of course, it is centered around larger municipalities almost exclusively, or large industrial developments in other places. Often the two are co-located. But if we go across country just very quickly, here's a snapshot from a couple of days ago in BC, and you can see that they're reporting the Air Quality Health Index. Same thing in Alberta. There's a scattering of stations. You can see there's a little bit of a bias or a higher concentration in the Wood Buffalo area and to the east of Edmonton, where you have a fairly large industrial sector. But it's scattered across the province, again, reporting in the Air Quality Health Index. Same kind of thing over Ontario. This is just, again, a snapshot from a couple of days ago. Good air quality out here. And then when we go to Quebec, il y a une situation un peu différente. And Quebec uses the index where basically they're picking the most significant pollutant and reporting it as an index. And so it was still all good air quality. But in fact, on this particular day, and this is in Gatineau, you can see that basically the contributor was in fact ozone. It was still in a good category, but the rest of them basically weren't a factor. So you have that way of getting an idea what the current air quality is. And then this is a snapshot from Environment Canada, which basically reports across the country at various locations. And it gives you a quick snapshot of what's actually happening right now. And so if you happen to live near one of these regions, it gives you an idea what you have there. But as noted, sometimes there isn't one that's particularly relevant to where you are. So that's a bit of a challenge. And this is where the Purple Air Network, and I've got a couple slides here to show you just because I think it's a really interesting tool that's being used in a number of different ways. And for a few $100s, you can buy a little disc, roughly the size of a small bowl. You mount it on a pole or on the side of your house. You plug it into power, it connects to your Wi-Fi, and then it feeds into this international, basically, connection of air quality sensors. It is only looking at PM2.5, and it can be reported in a number of different ways. This particular map that I'm showing here is the raw PM2.5, what it's actually calculating. This is not a research grade instrument, but when you get enough of them and they're close enough together, you start to come in a position where you can get at least an overall kind of picture. Every once in a while, there'll be one sensor that looks really weird, and you know that something's misreporting, or somebody's got a small fire going underneath the sensor or something. And if we zoom in, and I've picked Edmonton here kind of arbitrarily just because it's kind of interesting, you can see that there's a fairly high concentration of them. And if we zoom in even a little bit farther, you can see that somebody has aligned a whole row of them here along 92nd Avenue in Edmonton. So you can be pretty certain, just because that happens to be an industrial district, that is not people having them in their backyards, but somebody has set up a network to take a look at what kind of values they get along that particular road in an industrial area. And just for reference, this is actually the Environment Canada building in Edmonton, where the Weather Forecast Center is. And so people are actually using these for personal interest, but they're actually being applied in a number of different situations as part of the tools to get an air quality network, as part of the research tools, where you can deploy a low-cost instrument, and by making some consideration of the fact that it is not $5 or $10 or $20,000 instrument, but by getting a lot of them out there, you can infer a lot of information about the trends, and even if the exact specific precise values aren't always right on. So what was sort of advertised, we talk a little bit about models, how we actually do forecasts. And so I want to sort of spend a little bit of time with that, and then we'll sort of open it up for questions here in a couple of minutes. Broadly, you can look at two kinds of models that we use for air quality. One is a Lagrangian or a particle model or a puff model, where we basically release a particle or a group of particles and then watch where it goes in an environment. Now, we have to give it a wind field. We have to give it some kind of wind and turbulence parameters to make sense of that, but it's basically going to wander off. And a very typical way to do that is you release thousands and thousands of particles. And because they're statistically sort of scattered around the mean flow, you actually get a bit of a plume that develops, and you can see how it's going to disperse. The other approach is to use an Eulerian or a spatial grid. You basically have a grid of numbers, and you represent the entire atmosphere with a bunch of boxes that will have some kind of a horizontal distance and a certain height. And then you calculate what's happening to the chemicals or the species, the PM in our particular interest, what's happening in that box. And you sort of assume that it's more or less uniformly distributed through that box, and the meteorology that's going on around it is going to carry it, move it one way or the other, dilute it, move it up or down, and you have that sort of, again, that sort of three-dimensional situation, but it's all contained in a grid that includes the whole thing. Lagrangian system is computationally very efficient. Once you have your meteorology grids, once you have your meteorological fields, you know what the wind is doing, how it changes with height, how it changes over time in terms of direction, you can actually generate those particle trajectories or that group of particle trajectories extremely quickly. And so you could do tens or hundreds of fire starts quite rapidly. The Eulerian, because you have to calculate at every grid square at every time step, it starts to become very expensive. And so you need to have pretty substantial computing resources. It doesn't hurt to have the biggest supercomputer in the world for that one. So in Canada, these sort of show up in two different ways. The Fire Smoke Canada, or it's basically a Canadian implementation of the Blue Sky framework from the United States, is primarily a Lagrangian type model, where basically they release a lot of particles from a model and trace where they're going to go. That oversimplifies the model that they're using, but think of it that way because it's they generate the meteorology, and then from that meteorology, they run all these pollution or these trajectories of the pollutant from the fire. What they do is they pick the fires from the Canadian Wildland Fire Information System, which has a routinely updated sort of database of where fires are being located, primarily from satellite detections. And then it uses a trajectory model. The one that they actually use is run or is actually developed by the NOAA agency in the United States, and they use that as a trajectory model to move it over. One of the things that's interesting in this one is that they actually carry over smoke. So they don't necessarily start each run with a totally clean atmosphere. And so what we're seeing then is you start to get pretty realistic representation of what's going on. And this is from towards the end of May of last spring. And you can see that there's a number of different places, and where you have the high concentrations would be your emission sources, the fires that it is identified and working with. Where you have 4, it means that if you zoom in, you'd see there's actually 4 individual points under there. Here in Oregon, Washington area, you can see that there's actually 7. And then the broader area of smoke is a combination of what's being released and distributed during that particular model run, and as well as what was there from previous runs. And so you start to get a pretty good picture. And this is routinely updated as information comes in, and it's easily accessible on the web. So it's a very useful tool that way. The other approach, and this has also been mentioned earlier, is firework. And this is basically, it's a fully integrated meteorology and air quality model. And so what we're working here is we've got a grid that actually, depending on sort of which version, is covering all of North America, or perhaps a good portion of the Northern Hemisphere. And so you've got a very high number of locations, or high number of boxes, where you have to do those calculations of what's going on. So in terms of how the air is being carried horizontally as well as vertically, and also it starts to include or consider, I guess, the dispersion and the dilution of the whole thing. Similarly to fire smoke, basically firework, gets their fire locations from the Canadian Wildland Fire Information System, says this is where the fire is, and then both of those models, this one as well as that, basically makes a decision about where it's going to put that particular plume into the atmosphere. Is it going to start right at the surface? Is it going to start 1,000, 10,000, or 5,000 meters up in the atmosphere? And so working on that, then it starts to move it forward in time. So really what this is, it's a version focused to include smoke of the regional air quality deterministic prediction system, which is basically run on a routine basis for all air quality. It's run year round for air quality in Canada. In this fire season, they actually add these fire locations. And actually, someone might be able to correct me on this, but I think it is actually all run all year round. It's just there's not a lot of smoke being put into the model right now. If you take a look at it now, you probably would see some smoke down in the United States, but you wouldn't see a great deal happening in Canada, which is good. This has active chemistry that it evolves in the plume. It is taking that estimate of what's actually coming in there in terms of the chemical speciation, the kind of whether you have brown or black carbon, the kind of VOCs, a number of the other gases that are in there. And then over time, at each time step, it actually is processing some chemical equations to represent how that chemistry is likely to evolve. The display of firework subtracts out all the other pollution, so it only shows on their webpage the smoke contribution. So that's all that it's trying to represent. And so here's an example from last summer when we were sharing our smoke from Quebec and Ontario with our American neighbors and fumigating New York. I think actually the presentation, the presenter that Dr. Henderson showed is a very similar time frame to this particular thing. And what you can see on here is you can see the individual point sources where you're actually getting significant emissions into the atmosphere, and then how it gets carried along in the model and carried onwards. Now, again, I'm focusing entirely on PM2.5. You can extract other species out of this, particularly for a research function. But for considering what's actually coming in terms of smoke and from forest fire smoke, this is a really good way to go about it. So what's it all mean? I'll try and snap it together a little bit here. So I think it's important to know that the models give us, and maybe I should have highlighted this, a prediction of the future. A model is always a simplification. It's trying to accommodate a whole bunch of different things, but represents something that is likely to happen. And the other factor, of course, is that all air quality models are also driven by meteorology models. So the same limitations that happen in a meteorology model are amplified, if you like, once you start to deal with the air quality in it. So you have models that are building on models, and they sort of are, I think it's safe to say that the error or any kind of noise isn't canceled out. The other thing that I've put here, and this is maybe a subtlety mainly for modelers, but the information only goes one direction. So the meteorology drives the air quality, but the fact that we had a really smoky situation is not, in an operational sense, yet affecting what's going to happen. So if you have a really smoky situation, the temperature is not going to rise as much at the surface because you just don't get as much sun into it. And so that is not reflected in the models that you'll actually see on the web. There's been some experiments done with that, and it actually comes up with very different solutions, but it's a complicated problem. And so that has not sort of been released for prime time yet. It's still in the research mode. But the fact of the matter is that you have it isn't really a one-way situation. So all that to say that we have got a lot of sources of error, as discussed before. We don't always know exactly what the emissions are. We have certainly a lot of questions about what is actually in there, the chemical speciation, but also we don't always know exactly what the fuels are. We don't always know exactly how intense the fire was. And we also don't know exactly how much heat is coming out, which of course then leads into the question, how high up is that actually going? Where is it being injected into the atmosphere? Or how high does that column of smoke go, and where does the plume develop as we go downwind? We have the inherent variability of meteorology, and particularly if you're dealing with places like BC or a lot of places in Canada where you have significant topography, numerical models always have to smooth and average that out. And so you're going to have quite a bit of error that sort of creeps in just because we can't represent the meteorology adequately. The chemistry that actually goes, whether you have some or whether you have none, it's always simplified. There's only so many species that are included, and there's only so many reactions that could be included. Just for practical purposes. We try and pick the most significant ones when we're doing this kind of thing, but it's still an incomplete representation. And the resolution is kind of coarse compared to what we really like, particularly if you're dealing with significant topography areas. So the really cool thing, or the thing that continually amazes me, is that they actually work pretty well. They're giving you a really good indication of trend, and it's never as detailed or as precise as we would like, but it actually is a useful tool, even with all the caveats that we have to put into the whole thing. So I just want to give you a couple comments, a couple thoughts that I have, and that is that observations are key to really understanding, because that is an actual observation. There may be some noisy things in there. You might have to make a little bit of a judgment. But when you take a look at particularly something like the Purple Air Network, you probably have a station that is reasonably close to where you live. And you can make some guesses or some inference, I guess, of what it's likely at your particular location or where you're actually working. The models usually catch the trends correctly. So if the meteorology is fairly close, they're going to actually have a pretty good idea what the fire behavior is going to be. They're going to have a pretty good idea of what actually is coming out of there. And so if it's increasing or decreasing, the model is going to be able to represent that pretty well. However, there's some tricks with timing. It might not heat up. The fire might not grow as quickly. It might run overnight, which may not necessarily be caught by the model. And so some of the timing may not be perfectly. So the diurnal trends for sure, or even how fast that column of smoke moves along. The other part of that is that that column of smoke is highly three-dimensional. There was a case a number of years ago in Alberta where if you looked at the model and you looked at the satellite photos and looked at all those kinds of things, you thought the model was doing an absolutely fantastic job, which it was really, except that at the surface, the air quality stayed quite good for quite a long time. And essentially you had a layer of smoke that was hovering above the ground. And so it never actually encountered where the humans were. And so you have a strong three-dimensional problem, and you know, a few hundred meters can make a really big difference, something like that. In that particular case, eventually that plume hit the ground and it got really bad, very bad quickly. The other thing that's worth noting is that forecasts of something like the Air Quality Health Index does incorporate some human judgment. So it's strongly influenced, it's strongly guided by numerical models, but there is the opportunity for humans to actually nudge it one way or the other. So think of the model as giving you a really good idea of spatial context. You certainly can compare what's happening where you are right now. And for trying to make decisions of what's likely to happen, you will have a pretty good idea whether it's going to get worse or whether it's going to get better. And the trick will be to watch it over time to see whether the timing on all that is correct. So I've kind of run through this rather quickly, but wanted to leave it there, and I'll take any questions that people might want to throw my way. And I haven't been watching the chat at all. So
Thank you, Brian. Thanks for that overview and to talk to us a bit more about the models. There's one question so far in the chat. I think it's a really good question. So you talked a bit about the caveats or limitations of the models, but I believe, knowing this individual, that this is coming from more of an operational perspective. So if you could speak at a high level about any situation, so thinking fire ops, when smoke models don't work well. You've already alluded that it can be like it's only a one-way interaction with meteorology, but could you provide any specific examples where you would not have confidence in the smoke model?
Yeah, that's a really that's a really good question. I was trying to come up with another page, sort of quick rules of thumb. And here's what I would say, and is that in a complex topography, you're in a valley, fire's in a valley running up a hill, or you basically have an awful lot of topography around. It's going to take a while for the model to figure out what's going on, because it simply cannot see where that fire actually is. And so it's going to take see in a numerical sense. And so in that particular area near the fire, oftentimes the model is not going to handle the details of the smoke. You might actually have some very sharp edges on that plume that you'll have seen in the fire, whereas the numerical model is going to smudge it all out. In the mid-range, once it's actually started to move, you've had a number of hours for the model to sort of tackle the situation. It probably is going to be more reliable, sort of in that medium range kind of thing. And then as you get farther, both in time and farther away, that's where it starts to get a little bit muddier. So errors amplify over time typically, And of course, all the models, even the driving model, isn't going to be as good. So I would say anytime you're trying to make operational decisions and in an operational environment, it's do you actually deploy aircraft? Do you actually deploy people? How can you actually make those sorts of decisions? Boy, I wish there was some easy ways to do it. My sort of mercenary side says hire a meteorologist; they'll be really helpful. But it even having been in situations where I'm trying to give good guidance for smoke, sometimes we do a really good job at it, and sometimes we do not. But it is one where the overall trends are probably the most reliable, and the part that's most important for operational decisions is probably where we're still pretty weak. And speaking of meteorologists, I see Matt McDonald has his hand up. So
yeah, good morning, Brian. Thanks for a super great presentation. It was interesting to learn, what's going on behind the two models. I know that a lot of us at the BC Wildfire Service use most often, namely Blue Sky, Fire Smoke, and Fireworks. I just wanted to add some commentary. Like, I find smoke forecasting just super, super tricky. As you mentioned, the fire environment is so dynamic. These models are initialized looking at heat signals and smoke emissions, and not 2-3 hours later, these fires can really blow up into monsters of their own. And then all the dynamics that comes along with shading, right? As a fire emits impressive amounts of smoke, it then shades downwind fires and actually turns down that fire intensity and behavior. And I've seen numerous times where the smoke concentrations end up doing the exact opposite of what the model was forecasting because of that shading and because of that decreased in fire activity. And then, of course, in the summer, when we have the absence of big synoptic features driving the winds, a lot of our winds are thermally driven, right? And so the difference between shading and not shading, can affect temperatures by 4, 5, 6 degrees Celsius, and in turn, reverse your thermal circulation. So I've been caught many times with completely blown smoke forecasts. You think that it's going to do one thing and it does the very opposite. And I would be in agreement there with some of the comments in the chat that the firework tends to be generally better, I think, because it's involving more of that meteorology component. But yeah, just to say it's really tricky, and I look forward to better models if that's possible.
yeah, thanks, Matt. Very good comments. And I was just going to add too, is that I think there is some significant things that, and I didn't spend a lot of time with that, but fire smoke actually has the possibility of what they call a playground, where you actually can say, well, what happens if we were to start a fire here? Where is that smoke likely to go? It's not going to be perfect, but in firework, you have a relatively coarse grid, whereas fire smoke actually is working on a pretty fine grid in certain parts of the country. And so you don't get an answer, you get an indication. And I think it's really useful for someone to be able to say, well, if a fire, or if we were to do a backfire or something like that here, where's the smoke likely to go? And again, I think, Matt, you've emphasized it again. Anybody who's tried to do this, well, maybe I'll put it this way. When I first started working in fire, I was actually as a summer student, and worked in a weather office in Alberta. And my boss at the time said, he says, you have to be a little bit crazy to try and forecast the weather. But he says, you've got to be a damn fool to try and forecast fire weather. And I think that's absolutely correct. It's a very, very challenging subject.
Thank you, Matt and Brian. So there were a couple notes made in the chat. First off, an effort is underway to couple fireworks smoke emissions and concentrations with surface meteorology. That's good to know. And also a note that sometimes the hardest things to forecast can be, as both Matt and Brian noted, where the smoke plume will interact with surface temperatures. I don't see any more questions in the chat. If anyone has any, please feel free to post them in there. I was curious, not from a fire line perspective, but from perhaps a public perspective, what kind of confidence do you think we can have for interpolating between stations? when we're looking at the air quality map. This ties back to the question about perhaps rural or remote areas not having as great of data. Are there any things that we should consider, like how far is too far to be interpolating, things like that?
The waffle answer is it depends, but here is an answer that I will give sort of in a bit of a roundabout way. One of the things that I learned when I was doing weather forecasting is that ultimately we would do a forecast for an area, or we would make a prediction for an area, and people who lived in an unusual spot, it could have been shading, it could have been in a valley, it could have been some, they lived near a lake or something like that. The kinds of things that we generalized were never appropriate or entirely appropriate for them. So they sort of would learn to calibrate what was happening at their particular location. And you can do this statistically, actually, with you have different stations, how they change with elevation or change with exposure and stuff like that. But people who live in a certain area learn to say, oh yeah, the forecast is always 2 degrees high, or the wind is always out by this many degrees. That kind of works for smoke as well. The challenge is that sometimes with smoke, with temperature, you can only get so sharp a gradient. It's going to mix. But smoke can have these incredibly sharp edges to it. And so a sensor that is 20 kilometers away might be just totally blotto in PM, and you have almost nothing where you are. So you kind of have to watch it over time and become a little bit of an estimator of, say, okay, well, it's getting worse, it's now getting better. And you kind of have to learn to calibrate yourself a little bit. So how far is too far? I would say if you happen to have the good fortune of having a station within 10 or 20 kilometers, usually it's representative. If you have to work with something 50 or 100, it gets pretty hard to come up with something really reliable. And I appreciated Dr. Henderson pointing out the incredible options you have for little air quality stations. The purple air is, I think it's about $300 Canadian right now. But something like the AQEGS, I'm not as familiar with, but you can actually get a tolerably good PM sensor for about $50. I'm not doing advertisements for any particular firm here, but it's pretty amazing that what you can get. And then again, you start to learn what you have locally, and you can compare it to what's actually sort of a quote unquote official observation. Very much like people have thermometers outside their windows.
Thanks, Brian. Yeah, I guess it's that local knowledge, right, is always very important. And also I would imagine topography is going to be the great determinator in many ways when it comes to smoke, and looking at your vertical atmospheric profile. Obviously, if you got an inversion in and something's 50 kilometers away, you can maybe count on it. But atmospheric mixing, I guess, is very important. So I don't see any new questions. Oh, no, I don't see any new questions popping. Oh, there we go. Every time I say that, it's if I ever need questions, I just have to say there aren't any. So are there any efforts to incorporate fire behavior prediction system, the CFF-BPS, fuel types, potential overnight growth into smoke models?
Does Carrie Anderson want to answer that one?
He says, yeah.
Yes,
Carrie,
there we go.
Carrie, would you like to unmute? Okay, I don't know if Carrie's going to unmute, but he said yes. Do you want to go off that, Brian?
I'll go with that. Yes.
Am I on now?
Yeah.
Oh,
Go
I'm
for
on.
it.
Oh, wow. Certainly, there are efforts underway. We're looking specifically at a test fire in Saskatchewan that we're examining. It's obviously it's a tricky business. I mean, one could go to the other extreme and look at models like NCAR produces or Fire Tech, which are very sophisticated models that require supercomputers. But on an operational setting, we're trying to couple fire growth modeling with firework, but we're having, if I'm allowed to say, staffing problems, finding people to do the work for us. But there is an effort underway to try to link the two together.
Thanks, Gary. I think it's a really good point. The other thing I was going to mention, I think we probably are ready to wrap this up here, but sorry, lost my place in my notes here. I think it's worth noting that there is a lot of interest in this whole question about air quality that comes from fires, and there's a couple projects running at the U of T that are worth noting, and so keep your ears peeled for some information on those. One of them is, it's called BBCAN, Biomass Burning Canada. It's run by a bunch of mostly atmospheric chemistry folks, and it has representatives from a number of universities across Canada, where they're trying to look at exactly how does well, I guess to some degree, what's actually coming out of the fire in terms of chemistry, and also how does it change with time? And so there's a whole bunch of work going on with that. And I noticed on the call that we've got some folks here, also some graduate students who are working on their, I guess it must be their capstone project or something like that, that are actually looking at some of the health impacts. And I think it's worth noting that in addition to those two projects, there's interest certainly in the others on the south of us. All through the US, there's a lot of interest in how do we evaluate what's actually coming out of the fire, and how does it evolve? How does it change with time? So there's endless opportunities for reading on that for those of you who are interested. So with that, unless there's other questions, thank you for your attention. I think we've had a pretty long session for the day, so thank you everybody for attending. I'll turn it back over to Karen.
Thank you, Brian. Yeah, thanks everyone who hung in there. I know 2 hours is pretty long to sit and stare at your screen. We appreciate you for sticking around. So as you know, we're going to have a webinar every Friday this month. Next week, we're going to have Dr. Preston Klein from the Mission Critical Team Institute talking to us about more focused on mental health, incident commanders, high pressure decision making. So we're going to talk about residue and resiliency for people working in high pressure situations. Week 3, we're going to bring it back to more of a physical health. We're going to look a little bit at presumptive cancers, but more focused on exposures and potential mitigation measures with Dr. Paul White. And then in week 3, we're going to have, I believe, 7 different presenters from the BC Wildfire Service, as well as Canada Wildfire, talking to us about different projects ongoing right now in Canada, looking at firefighter health. We're going to have an occupational hygienist. We're going to have a whole bunch of different people talking to us. So it's going to be really great. Firefighter fatigue. We're going to look at smoke on the fire line and impacts and mitigations, all that great stuff. So again, thank you so much for joining us today, and we hope to see you next week. Have a great Friday, everyone. Bye-bye.